second question. In this case, I have to tackle implicit differentiation, but using product rule. So let me give myself some space. There you go. Now I need to find the differentiation of this. Again, this is implicit differentiation because I have x and y together. So using product rule, what I have to do in here is I'm going to call the first term u, and I'm going to call the second term v. So I'm going to say u is equal to x and v equal to y. Then du over dx, that becomes just 1. dv over dx, this is going to become dy over dx, because differentiation of y with respect to x, that'll be 1, and since this is y, so we're just going to call it dy dx. Now what I've got to do is, according to the product rule, so u multiplied by dv dx plus v times by du dx. So I'm going to highlight u, that's u, and then I'm going to multiply it by dv dx. So this is my dv dx, here you go. And then what I'm going to do is I'm going to multiply v times by du dx. So v, here you go, that's my v times by du dx. So if I follow the method here, so I need to multiply x times by du dx, so it's going to become x, sorry, my mistake, times by dy dx, so x times by dy dx plus v multiplied by du dx, so v, which is y, times by du dx, that'll be just y. Now, in the next step, I need to make dy dx the subject. So I'm going to say, so I'm going to move over here, so I'll write my answer in here. So dy over dx, x will be equal to minus y. Okay. And if I move positive y on the other side, that's going to become negative y. And therefore, dy over dx, that'll be equal to minus y over x. And that will be my final answer. You may come across some questions where you need to use product rule to tackle implicit differentiation, and you can follow a shortcut. For example, if you see the differentiation of x, y would be equal to minus x over y. So in some cases, you can use the shortcut. Now I'm going to go to the next question, and then I will use a shortcut if I come across differentiation of x and y. Now in here again, I need to use product rule to tackle implicit differentiation. Now, what I'm going to do in here, so I need to differentiate x squared, I need to differentiate xy, and then also need to differentiate y squared equal to 1. So I'm going to differentiate every term in here. So the differentiation of x squared would become 2x plus. Now I'm going to use a shortcut in here because I just worked out the differentiation of x multiplied by y should become minus y over x. There you go. So differentiation of xy became minus y over x. So I'm going to replace that to minus y over x plus differentiation of y squared. That becomes 2y dy over dx equal to differentiation of 1 becomes 0. Now what I'm going to do is I'll move this on the other side of my equation. So I'll move this over there. So I can make dy dx a subject. So I'm going to end up with 2y dy over dx equal to, now if I move one at a time, so this is negative, this is minus y over x, so uh, if I try to move, okay, one at a time, so that's going to become positive y over x minus 2x. There you go. And then I can make dy dx a subject, so dy over dx should be equal to y over x minus 2x divided by 2y. And this is my final answer. And in here, I'm going to use product rule to tackle implicit differentiation. So I need to differentiate x squared y squared plus x squared plus y squared. So what I'll do in here is let me differentiate x squared y squared first, and then once I got my answer, then I'll write my answer, then I'm going to continue to differentiate the rest of them. Okay, so I need to differentiate x squared y squared. So as you know, they're product of one another. So therefore, I'm going to use product rule in here. I'm going to say u is equal to x squared, and v would be equal to y squared. Du over dx equal to 2x. dv over dx, that becomes equal to 2y dy over dx. Now I can use product rule to multiply them together and then get an answer. So according to product rule, so it'll be u times by dv dx. So here I've got u multiplied by dv dx plus v times by du dx. So v, here goes, so v multiplied by du dx. So therefore, if I multiply these two together, I'm going to get x squared times by 2y dy over dx plus, here you go, so 2x y squared. Okay. Now, all of these, they are the differentiation of x squared y squared. So I'm going to try to write the rest of my answer in here. So I'll change a color as well. So therefore, now we have known that differentiation of x squared y squared is, if I could simplify this as well, so that's going to become 2x squared y dy over dx plus 2x y squared plus, now the differentiation of x squared will become 2x. Differentiation of y squared becomes 2y dy over dx equal to, now differentiation of 2 becomes 0. Okay, as you can see now in here, I ended up with dy dx here and dy dx here. So I'm going to keep dy dx on one side and then remove everything else on the other side. So if I do that, so I'll end up with 2x squared y dy over dx plus 2y dy over dx equal to, I'll move anything which is not been multiplied by dy dx. So for example, here I've got 2xy squared and then plus 2x. So equal to, so they're both going to become negative. So minus 2x y squared minus 2x. So I've moved, if I highlight, so I'll move 2xy squared, so that's going to become minus 2xy squared, and positive 2x will become negative 2x. Now from here, I'm going to factorize this so I can have dy dx by itself and then make that a subject later on. There you go. So when I factorize dy dx, I'm going to end up with 2x squared y plus 2y equal to minus 2x y squared minus 2x again. So finally, dy over dx become equal to minus 2x y squared minus 2x over 2x squared y plus 2y. And this will be my final answer.